Let's say you have a method that does the following: downloads an image from the internet, creates several copies of the image but resize them, shows the original image and the copies on the screen. For this to work, this method is called within a feature builder. We show a loading widget while the process is running, and once the images have been generated, they are shown within a list. The last step is to assign the previously created method to the future variable so it will be executed as soon as the app starts. If you try to execute this code, you'll notice the user interface becomes sluggish, possibly even unresponsive. It seems like I've frozen the video, but no, this is actually what happens to the app while the images are being processed. The reason for this is that even though Flutter provides us with a mechanism to execute asynchronous code via features, both synchronous and asynchronous code is actually executed on the same thread. Taking into account that working with images is expensive, part of the CPU load in carrying out these processes makes the fluidity of the application suffer, resulting in the image freezing for a few seconds until the image processing is over. In this video, we'll see how to move intensive computation to a Flutter background thread using the compute method, which is part of the Flutter SDK. The compute method is intended to make it easier to work with background threads in Flutter. Specifically, in the context of Flutter, these threads are called isolates. And although we can call and use them in different ways, in today's example, we will see how the Flutter API handles all these tasks when working with compute. Isolates have a completely separate memory space from other threads, so they cannot access instances created from another thread. For that reason, we will move the method that downloads the image outside of the widget class to convert it to a top-level function. But a static function will also work. Now, we are going to modify that method so that it can work correctly in a background thread. Specifically, we will create a class that represents its parameters. We will also have to pass the temporary directory as a parameter since background threads have problems when executing platform code, and the method getTemporaryDirectory is actually calling native platform code. Now, we will create a method that initializes the future by calling the compute method using the top-level function name reference and passing the parameters class we just have created. If you try to execute this code now, despite the processing time for all the images being approximately the same, you will notice that the UI does not freeze. The loading widget we have implemented continues to spin throughout. This is because we have shifted the resource-intensive task to a background thread, allowing the main thread to maintain a smooth interface movement. Flutter incorporates different ways of working with threads. As I have already commented in the video, these are called isolates and they can be called directly, controlling each of the steps of their life cycle. However, for simple tasks that only run for a few seconds and then complete, it is better to use the compute method, since it abstracts us from the relevant management of those threads. You can find the complete source code for this project in the video description. Please leave me a like if you found this video useful and consider subscribing for more Flutter development related topics. Thank you for watching. Goodbye.